Today we're going to look at lesson 3.1, functions and relations. Can anybody tell me what they remember about relations? What about functions? Do you remember anything you've learned about functions? The good news is, since none of you can tell me anything about functions, you're going to enjoy the essential question today, which is, what is a function? So they expect by the end of the lesson you to be able to answer that question. Now, look at a relation. Let it make sense. It says relations, they pair inputs with outputs, okay? Now when I say let it make sense, let's talk about real life for a second. If someone is in a relationship, how many people are typically in the relationship? Two, okay? So a relation pairs two things. It pairs inputs with outputs. Now that leads me to a function, all right? I've given you a relation. The question is that relation a function? Well, here's your definition of a function. For every input, or domain, there is exactly one output, also called the range. So, fill in those blanks, and then I want you to highlight domain and range. Here's why. We are going to learn about domain and range in this chapter, and we are going to keep talking about domain and range into the rest of the book. So domain and range is not going anywhere anytime soon. So I want to make sure that you really fully understand it. So when we're talking about input values, we also are talking about the domain. And when we talk about the output values, we're also talking about the range. Okay? But here's a function. For every input, there is exactly one output. Now let's look at example 1. It says determine whether the relation is a function. So look, these are relations. These two problems are pairing inputs and outputs. What do we call these things in letter A?
Ordered pairs.
Ordered pairs. Very good. So an ordered pair is a way that we would display a relation. What are we looking at in letter B? What do you call that? A chart, an X and Y chart, an X and Y table, okay? But also they're pairing inputs and outputs. So this is just different ways that we can display relations. But do you see how they're relations? They're pairing an input and an output together. But the question is it a function? And here's what we're going to do. We're going to focus on X. So I want you to write that down, all right? This is just a good little note because the quickest way to determine whether these relations are functions is to focus on X. Now, I want you to look at the ordered pairs. All right? Somebody raise your hand and name for me all the X values in these ordered pairs. Victoria.
-5, 0, 5, 5.
-5, 0, 5, and 5. So here's the question you have to ask yourself. Do any of those repeat? Yes or no?
Yes.
Which one repeats? 5. So I want you to either draw a little arrow to each 5 like I am. You can highlight it. Do something to where it sticks out because this is how we determine if it's a function. If one of our X values repeats, we have to stop and look at the outputs. When the first 5 went in, what came out? 0 came out. When the second 5 went in, what came out? 10. So, for every input, was there exactly one output?
No.
So is this a function?
No.
No. So not a function. Now, if I were to ask you to explain, you would write something like 5 had 2 different outputs. I mean, that's the explanation. That's how we knew it was not a function. Let's look at letter B and let's focus on the X values again. What are the X values on this table? Class.
2, 4, 6.
Did any of those X values repeat?
No.
Guess what then? It's a function. This is why I want you focused on the X. Do you see how quick? If none of my X values repeat, it's a function. Because if there's only one of every input, then obviously for every input, there is only one output. All right? So that's why we're going to focus on X. If none of your X values repeat, it's a function. If they do repeat, and you look at those outputs and they're different, it's not a function. That leads us to example number 2. It says determine whether the graph represents a function. So I would do this. I would go ahead and highlight the word graph, because if I put this on a quiz or a test, I'm not going to tell you how to determine. All right? I'm telling you in the notes how to determine, but I want you to highlight the word graph, and then I want you to look at what I've told you to do. The vertical line test. Now, technically, we could sit here and we could pull all the points off of the circle in letter A and all the points off the parabola in letter B. And then we could do what we just did. We could look at all of the x values and see if any of them repeat. But who in the world wants to take the time and do that? So there's something called the vertical line test. First of all, let's go back in our minds. Vertical. Up or down, right or left? Up or down. Because if you don't remember what a vertical line is, you can't do the vertical line test. All right? But look at the vertical line test. If a vertical line passes through a graph one time, the equation is a function. Now, you might want to write in there exactly one time. Maybe that'll help you. Okay? It's one time. If the vertical line passes through a graph one time and one time only, the equation is a function. So, when I do a vertical line, I typically do a dotted line because I don't want it to look like part of the graph. But I can start this vertical line anywhere I want on the graph. And listen, the graph in letter A is the circle. The circle is the graph. All right? So I start at the top of my coordinate plane from any spot, and I work that vertical line all the way down to the bottom. Now, how many times did my vertical line hit or touch the graph? It passed through once, twice. So is this a function? Not a function. Because remember, the vertical line test says if a vertical line passes through a graph one time, the equation is a function. This vertical line passed through the graph twice, so it is not a function. When we do the vertical line test on letter B, and it doesn't matter where you start, some of you may have chosen to start over here, some of you may have wanted to do it over here. No matter where you start it, how many times does the vertical line pass through your graph? Once. It passes right here, it passes right here, but it only passes through one time. So is this a function? Yes. This is a function. How many of you said on your paper it was a function? All right, good. Just make sure you proved it with your vertical. Now that takes us into example number 3. And you can see that I have added some things that you do not have on your notes, but I would add these to your notes if I were you. It says, give the domain, which is your input values or your x values, and the range, which is your output values or your y. Okay, do you see we now have 3 different ways to talk about the domain. We can use the word domain, we can talk about the input values, or we can talk about the x values. They all mean the same thing. And the range, we can call it the output, we can call it the y values, it's the range. But they want us to look at these functions and they want us to tell or give the domain and the range. Now, letter A is a piece of cake because you have ordered pairs, right? So let's go ahead and let's write down the word domain and let's write down the word range and then let's list them. Please make sure they are listed in, not alphabetical, that would not work, in numerical order. And if you want to make a note because we're going to do it that way. I'm going to expect it that way every single time. All right, so the domain. And you know what? We could even do this if we wanted. We could put a little X in parentheses next to the word domain. And we could put a little Y. Anything that's going to help you remember that the domain is the X values and the range is the Y values. Okay? So what is the domain? Jamie, what's the domain of this particular problem? 1, 2, 3, 4, 5. Awesome. And it just so happens that I already gave you the ordered pairs in numerical order. So 1, 2, 3, 4, 5. Noah, can you give me the range of this problem?
-2, 1, 6, 13, and 22.
There you go. -2, 1, 6, 13, and 22. So again, all of the y values are the range. And these are already in order from least to greatest. Okay, so that one's pretty easy. If I give you ordered pairs, the x values are my domain, the y values are my range. But what happens when we start moving on to graphs? Okay, if you look at letter B, there's not a line, there's not a parabola, there's not a circle. There are 4 points. Okay, so here's what we're going to do. We're going to find the ordered pairs of those 4 points, and then we'll be able to easily give the domain and the range. All right, now, quick review before we do anything. When I'm plotting points, I start where in the coordinate plane? Anybody, where?
The horizontal line with your X. The 0.
Where do I start? 0. I start in the middle, okay? I start in the middle. So we're right here. And when I go to plot a point, okay, we're going back to 7th grade for just a minute. When I plot a point, do I move right or left or up and down first?
Up and down. Right or left? Right or left?
Right or left, okay? It's the x-axis. I move along the x-axis and then I move along the y-axis. So keep that in mind because we need to identify this first point here at the top. Kennedy, tell me what the ordered pair would be for this first point. Okay? -2 what?
4.
All right, good. So if I start in the middle, like we talked about, I move left to -2 so that I'm lined up with the point, and then I go up to 4. So she's exactly correct when she says that the ordered pair is -2, 4. Now you can put it beside the point. You can list it over to the side. I don't care. Just get these points down. All right? Rogello, what is the ordered pair for that point that I've circled on the screen? Careful. This point right here. -1, 2. If I start in the center, I go left to -1. That lines me up with the point. I go up to 2. So she is correct when she says -1, 2. Sarah, can you tell me the ordered pair for this third point? Right here.
1, 2.
All right, if I go right to 1, I'm lined up, and I go up to 2. So she is correct when she says 1, 2. And Zach, what is the ordered pair for this last point?
2, 4.
All right, 2, 4. Let's check. If we start in the center, we go right to 2. We're lined up with the point, and then we go up to 4. All right, very good. Now that we've listed the coordinates for every single point, what is the domain of this graph?
-2, -1, 1, 2.
Good. And he gave it to me in order from least to greatest. -2, -1, 1, and 2. Ayana, what would the range of this graph be?
2, 2, 4, 4.
Say it one more time.
2, 2, 4, 4.
2, 2, 4, 4. Again, she's put it in order from least to greatest. Now, you look at letter C, and we have a parabola again. But I want you to look back real quick at the parabola in example 2. And I want you to tell me what was on that parabola that you don't see on letter C. On the ends. There were arrows, right? So if there are arrows on the end of a parabola, your domain is going to be all real numbers because that parabola goes off in both directions forever and ever without ever stopping. That's what the arrows tell me, right? But this parabola in example 3 does not have arrows because this parabola comes to an end. It ends here and it ends here. Okay? We could say it starts here and it ends here. All right? But we have definite endpoints on the end of our parabola. So that's going to make finding the domain and the range a little bit more difficult. But let's go ahead and write the domain. Now, we've been going over this all day. The domain represents what set of values? The x. So I'm going to go ahead and put an x down, but I want you to notice where I put it. I left space to the left of it, and I left space to the right of it. Because there is a definite a beginning and a definite end to this parabola. So I want you to look, if we go as far left as we can, and we say, where does this parabola start? At what x coordinate does this parabola start? What would you tell me? -2. You say, how did they know that? Because if you follow the point down, it's at -2 on the x-axis. So the first number I'm putting in my domain is the -2. Now go to the other end of the parabola. Where does this parabola end on the x-axis? Again, if you're like, how do they know that, Ms. Johnson? Because they're looking all the way down and they hit 3 on the x-axis. So the second number in my domain is 3. Now the question is, what does it look like we're writing as we do this? No. We've got X in the middle.
Oh, an and problem. No, and.
Okay, it's an and problem, but it's what kind of an inequality? What do we call that? Compound inequality. That's exactly what we're writing. So listen, when your graph has a beginning and an end, your domain and range are going to be compound inequalities. All right? So be aware of that. That's what's happening here. This graph has a definite beginning and a definite end. So our domain and range are compound inequalities. So now we got to figure out the symbols. So I want you to go back again to where this parabola starts. And I want you to understand, if we start here, we move over here to the other side, right? So are my numbers getting larger than -2 as I move to the right, or are they getting smaller? They're getting larger. So X is actually greater than or equal to. Why or equal to? Because -2 is on the graph. It's included. So -2 is less than or equal to X. Okay? Or X is greater than or equal to -2. Now you got to go to the 3. So now we got to go and start over here. If we start at 3 and we move to the other side of the parabola, are the X's getting smaller or larger? Now they're getting smaller. So X is less than or equal to 3. So the domain is only from -2 to +3. We're going to do the range. The range deals with which set of values? Y. So we're going to do the same thing. We're going to put Y in the middle. Now, we're also going to make a small change to this parabola. See how it kind of drops below -2? I don't want to deal with decimals. So I want you to kind of redraw and make it just be right on that -2 line. Okay? So here's the question. How low on the y-axis does this parabola sit? At -2. So guess what? The first number in our range is going to be -2. How high does this parabola go on the y-axis?
4.
It goes to +4. You say, how do you know? Because this is numbered up through 3. See how the lines? You got 1, 2, 3. So naturally the next line would be 4. All right? So we know 4 is the second number in our range. Now again, we have to think. If we start at the bottom of the parabola, are the numbers on the y-axis, are they getting larger than -2 or are they getting smaller? They're getting larger. So again, y is greater than or equal to -2. But if I were to start at the top of my parabola, if I were to stop up here or start up here at 4 and move, are the numbers getting smaller or larger? Smaller. So y is less than or equal to 4. And that is the domain and range of a graph that has a definite beginning and a definite end. Now you might want to make yourself that note next to letter C. Something about the fact that this graph has a beginning and an end. It's not points. It's not a line that goes off in both directions forever and ever. This graph has a beginning and this graph has an end. Now the last thing we're going to look at is the independent and the dependent variables. All right, so stay with me because I'm going to try to make this as simple as I possibly can. You see that the independent variable, it represents the input values. You say, Ms. Johnson, how can I remember this? Well, independent starts with the letter I, and so does input values. Do you see that? All right. Now, let's add a couple more things to this. What's another way that we have talked about input values today? X. Okay, let's put X and domain. Perfect. So if you write this down, now you have all the possible choices for X in one spot. We can call them the X values, we can call them the input, we can call them the domain, or we can call them the independent variable. And you know what? After I write it down, I think it'd be a great idea if you highlighted independent variable, input, X, and domain. Now, the dependent variable starts with D. All right. It represents the output values. You say, Ms. Johnson, how can I remember that? Well, do. D-O, right? Do your work. So the dependent variable represents the output values. What are some other things we've called the output values today? The y values, so we can add that, and the range. Good. So once again, we have everything in one spot. The dependent variable is the output, it's the y values, it's the range. These words are interchangeable with each other. So highlight dependent variable, highlight output, highlight y, and highlight range. All right? Now, if you saw the problem, and I'm just going to write this down over to the side. If you saw the problem y equals mx plus b, and I asked you which variable represents the input, what would you tell me? X. And if I asked you which variable represents the output, what would you tell me? Y. Okay? But you can see in our problem that the function we're working with this time is a equals negative 4b plus 14. However, can you see the similarities? Yes, okay? So let that help you. In this function, what would you call the input value? If a is equal to negative 4b plus 14, and you see the similarities between this and y equals mx plus b, what would you think the input values would be in this function?
Negative 4.
That's not a variable.
Oh, B.
B, okay, good. So I would make a little note here and put input. And then which variable looks similar? If we're comparing it to y equals mx plus b, which variable in our problem looks like the output? A, all right? And I'd make that little note there as well. So, if they want me to identify the independent and the dependent variables, what would be the independent variable? B, right? Because we just said the B appears to be the input. So we would say B, comma, batches. Okay, we're going to put the variable, but we're also going to put what it represents. And if you read the problem, it says B, batches of guacamole. All right, and then let's talk about the dependent variable. What's the dependent variable? The output, right? The A. And that represents avocados, right? The avocados that are left. So we can pretty quickly, hopefully, especially if we can keep in mind y equals mx plus b, we should be able to figure out the input and the output. If we can figure out the input variable and the output variable, then identifying the independent and the dependent should be pretty simple as well. Okay, but let's talk about real life. Everybody wants to know, when do we use this in real life? So let's talk about real life. If somebody is independent in real life, what does that mean? They're by themselves, right? They do whatever they want. They go to bed when they want. They eat when they want. They do whatever they want, okay? But you, right now in life, are very much dependent upon who?
Your parents.
Your parents. You're not going to the mall if your mom doesn't take you. You're not going, or an adult. You're not going to eat if your mom doesn't grocery shop for you. Okay? So you are dependent. I could be considered independent, right? I'm an adult. I can go and I have a family, so I actually can't. But I'm an adult, right? I can drive myself places. You are very dependent. So when you're looking at a problem, if you're still confused, if you're looking at a problem and you're like, Ms. Johnson, I don't get it. Okay? Then ask yourself this question. Does the number of avocados I have left, can I have any number of avocados left that I want? Or can I make however many batches of guacamole that I want? The batches. I can make as many batches of guacamole as I want. So that is my independent variable. All right? But it depends on how many batches I make, on how many avocados I have left. All right? Now, number 2 says the domain is 0, 1, 2, and 3. Let's not let the word domain throw us off. What else is considered the domain?
X.
The X value, okay? Of course, in this case, in this particular problem, what is the X value or the input? B, okay? So when we make this cute little chart that we're going to make, we have to put B first, and then we're going to input the function. And our function is a equals negative 4b plus 14. And of course, once we plug in those b values, a is going to come out. So our little chart has the b or the input, the function, and then the a or the output. Now, they told us to use 0, 1, 2, and 3. So they have told us we're going to make 0 batches, 1 batch, 2 batch, and 3 batch. Now, when we plug numbers in, we plug numbers in parentheses, because what are we supposed to be doing to negative 4 and b? We're supposed to be multiplying. So if we plug the numbers in parentheses, we hopefully will not forget to multiply. So negative 4 times 1 plus 14. A equals negative 4 times 2 plus 14. And A equals negative 4 times 3 plus 14. Now, we've got to kind of push everything we did with equations to the back of our mind and answer the question, do we multiply first or do we add first? Because to solve this, we have multiplication and we have addition. Which one, if we follow, please excuse my dear Aunt Sally, which one are we supposed to do first? We're supposed to multiply first. Really? My dear is multiply or divide. Aunt Sally is add or subtract. So we're going to multiply and then add. What's negative 4 times 0?
0.
Plus 14.
14.
What's negative 4 times 1? Negative 4 plus 14? 10. Negative 4 times 2? Plus 14. And negative 4 times 3? Negative 12 plus 14 is 2. But we're not done because the question says, what is the range? So let's list the range. What is it?
14.
Good. Least to greatest. 2, 6, 10, and 14. So what have we just discovered? If we make no batches of guacamole, we have 14 avocados. If we make 1 batch, we have 10 left over. If we make 2 batches, we have 6 left over. And if we make 3 batches of guacamole, we have 2 avocados left over. And that is lesson 3.1.